Well, hello, everyone. It's Ed here again at the Geolytix Podcast. Hope you enjoyed the first episode with Blair, where we talked about what Geolytix does as a company. We're going to drill in a little bit more now into the data side of what goes on in terms of location analytics. I've got two of Geolytix stars with me here that's going to explain a little bit more. Do you want to introduce yourselves and tell us a little bit more about Geolytix if people haven't heard the first podcast?
Yeah, I'll go. So I'm Alison Moriarty. My job title is Head of Location Planning at Geolytix, but I guess Geolytix is all about location planning, so that's our world. So we help primarily retailers, but other businesses as well, essentially with their location decisions, so optimizing their store networks. Where should I open?
So I'm Daniel Hart, so I'm head of data science at Geolytix. And yeah, I think I've been with Geolytix maybe sort of 9 years-ish now. So our department is mostly about building models, sort of running analysis, that sort of thing, try and solve location planning problems. My personal remit is mostly international rather than the UK, but not necessarily exclusively.
Okay, that's an interesting perspective because I guess probably most of us listening to this podcast will be familiar with the UK or maybe the United States, where I think we have a sense probably as individuals that there's an awful lot of data that's used in store location and in the analytical activities that you do. Perhaps we didn't understand or didn't really understand that actually this is a global activity, or we're trying to do the same sorts of activities everywhere. So at that fundamental level, what type of data are you guys using to do, location analytics?
No, it's a great question. I'd say it varies massively depending on the market. So we're really blessed in some markets to have great data, open data at our fingertips. I think, say, for example, if you're doing a project in Australia, one of the best sensors in the world, all the way down to income data, for example, at really granular geographies, brilliant to work with. You might be working, for example, on a project in, say, Mongolia, where maybe data is a little bit harder to find. So yeah, I would say that generally speaking, our data sort of comes into a few different categories. So some will come from, say, the census type variables that you typically expect, so population, demographics, all of that good stuff. I think in addition to that, mobility data, I think it's been one of the sort of key breakthroughs over the last sort of number of years certainly made my job a little bit easier in terms of being able to see where, busyness is, whether it be vehicular busyness, proxies for footfall, that kind of thing. So really just bringing to life actually whereabouts on a particular street, for example, are we seeing the sort of highest density of activity.
Let's drill into that a little bit. Sure. I think most of us probably got a sense of what population data is. We've all probably filled in a census at some point. We understand how that data gets used and used a lot by governments. What do you mean by mobility data? What's that?
Yeah, sure. So mobility data, we're basically speaking about when people are using their mobile phones and that generating some sort of, we tend to call them pings. And all of those pings basically are aggregated up at a sort of anonymized level. And then we can use that to try and track activity of just whereabouts within a city, for example, are the busy spots. And we actually use it beyond that as well. So we can use it for things like catchment analysis, for example. So understanding how far are people traveling to the places they're interacting with. Also, from that, we can start to learn about things like decays. So, for example, if you're visiting a supermarket, yes, you might be traveling from this distance away, but also kind of what proportion of people are traveling from great distances to very short distances. And all that can be really helpful for when we actually build the forecasting models, because then we effectively understand people's propensity to spend, or at least a sort of per capita sort of weighted ratio there. Yeah, so it's been really, really helpful for us, mobility data in recent years.
So I guess this in some way helps you out with that issue with that kind of population data. That census data was relatively static. It didn't change very often because we only ran a census every 10 years. Does mobility data fill that gap for you, or is it more specific than that?
We probably use it for more specific use cases than population estimates, but you certainly do have some data you can get from sort of home location of the device versus work location of the device, and can sort of use it to layer on top of things like census data that's a bit more static, because it is a much more recent view of where people are and where they're static for periods of time. So you can sort of infer a home or a work location, which is quite useful.
Yeah, and I think that's a kind of a useful insight, isn't it? Because I think often we think in terms of traditional maps, and perhaps we've used a geographic information system, and we look at data as being relatively static, not something that changes very often. But actually, we are dealing with very, very dynamic data, and having all of those different insights that you guys can find from different sources of data. So we have population data, we have mobility data about people moving around. Let me just focus in on this. How do you make sure that is anonymized? Because that sounds a bit creepy to me.
So thankfully, that comes from the data team rather than ourselves. So that's a bit of a cop-out answer. But yeah, so in terms of there's no PII attached to any of that, so there's no personally identifiable information attached. So what we'll tend to get is basically some grouped, we don't know what the apps are that they're using or anything like that. My understanding is that it's basically, we understand the frequency of how many pings we're getting from that specific device, but that device is not necessarily attached to a single person or anything like that, at least not in the form we use it. Additionally, when we're actually using it for any of the modeling activities or anything like that, we're never looking at individual devices. We're looking at basically what's been aggregated up to a hex level. These are basically some H3 grids that we use, and nobody's ever heard of those. Basically, you can divide the world into lots and lots of sort of small hexagons at varying scales. So we tend to use those for a lot of our analysis. So understanding, for example, how many, or basically like what's the overall busyness based on the mobility data at this specific hex. So at that level, yeah, it's basically been aggregated to the point that you wouldn't be able to identify anyway.
So I guess there's value in having that kind of an abstract view of the world where you're not defined by council boundaries or other types of geography. You're taking a very an abstract sense of the world.
Exactly.
Well, let's kind of put this into a concrete use case. Let's say I wanted a hobby of mine is photography. I wanted to set up a photography shop somewhere in, I don't know, southwest London. What type of data would I be using to help me model where my potential customers would be?
Would say this one else?
Yeah, can do. I guess first thing you'd want to understand is who are my potential people who are going to spend a lot of money on photography equipment.
Yeah, you always spend a lot of money on photography
my understanding
equipment,
it's quite expensive. So, so I guess one layer in that process would be a sort of demand surface of some sort of representing people's expenditure on the category that you're selling. So there will obviously be certain patches of demographics that would spend a lot more. So we would start with that sort of, which is population, various other attributes that would define that sort of demand. Then I think Danny sort of alluded to this decay effect. So obviously the closer you live to a photography shop, you're more likely to spend there if you pass it every day.
The first law of geography, near things are more important than distant things. I'm glad we covered that. At some point, it was good that we got that. Thank you.
So,
you've revealed the big secrets. It's all out now.
Okay, so yeah, there's some sort of distance decay.
Sort of distance decay. And then you need to start thinking about the attractiveness of the location that you're opening in. So are there other things that are drawing people to that location? So then we'd layer in all these other, particularly in the UK, all these cool data sets we've got about retail places, the strength of that retail place, whether there are other benchmarks that are sort of similar profile retail outlets that a customer of your photography shop would also be interested in going to. So obviously another geographical rule, but sort of this attractiveness thing. So bigger, more attractive centres are going to have a bigger pull. So people are more willing to travel and spend there. So we'd be sort of modelling that combination of demand and supply to figure out where, there's the highest probability of achieving high sales for that kind of outlet. If it was your first one, we'd obviously be making some assumptions about how people might behave and spend. If it was your 20th plus one, we'd have quite a lot of data about your existing estate that we could use to fit a model to and essentially try and predict a turnover for that location.
And I think that's really important to kind of focus in on that point that, we are talking about predictive models here. We put some data in, we can say, well, we understand your customers, therefore we think this is likely to happen. And then you can iterate around that process as you get better data as things progress. That's fantastic in the UK. We've got lots of data sets that you're talking about. I'm really interested in this idea of a place and and how with your data you can recognize the characteristics of one place as different to another. I think in an earlier podcast, Blair mentioned this idea of, can we identify places that are like Camden? Is that what we're talking about? Is sort of fingerprinting the nation in that way?
That's one of the ways we can approach it. So we sort of call it potentially an analog model. So we would say, tell me which 4 or 5 places are most similar to this place. It wouldn't have to be the UK. It could be anywhere, but we'd sort of use some different criteria and weightings to say, these are the 10, 20, 30 things that feel most important to make sure this place is similar to another one. And I think you did a cool high street analog piece of work, didn't you, for heritage? We have done actually. Yeah. So I think it's analog models are really interesting. So I think versus maybe the sort of more traditional data science type models of regression problems and sort of classification problems, they're very interesting in that they're immediately interpretable. And because I guess place is something that's quite personal to people, and that sort of idea of you sort of saying, well, I know that my town has these characteristics. Some of those can be fairly abstract. So analog models are really interesting in that you can bring together the variables that you think might help make up a similar place. So that might be, for example, simple things like, say, income proxies, for example, in terms of understanding sort of levels of either deprivation or wealth or whatever it might be. It could be about the industry that's within a specific location. It could be about, in our context, typically the kind of retailers that are in a location, or access to transport, etc. And you can create an analog model that basically helps identify which places are the most similar. And actually, typically when you do that, it does sort of come to life a little bit and say, yeah, well, actually, I do think that I can see the resemblance between my town and that town because it might be fairly local and I've been there and it's fairly similar. So I think people can get quite emotional, I guess, about place. And I think analog models are quite nice in that they're a bit less abstract in terms of the result than maybe a regression problem is, where there's maybe 15 variables gone into a model, you get a number out at the end. And really, really important, especially for location planning, in that you want to know how much your store is going to make before you open it. Ideally, it's going to be profitable. But yeah, I think analog is definitely an alternative lens for understanding the sorts of places you might want to go into. That's maybe not quite simple as just,
And as you say, I think it's something that all of us can sort of conceptualize. We understand as we travel that, this place feels like wherever, or, I know how, the lanes in Brighton feel different to if I'm shopping in, a supermarket in the Northeast. It feels different. And I guess, I understand where you're coming from in terms of the data that you might use in these regression models. But for the analogs, are you talking about different types of data that you're using? And how do you have a data insight in what a sense of place is like?
It's really interesting. So if I was to build an analog model for the sole purpose of creating a forecast, I'd probably do it a slightly different way, in that I might use some sort of R-squared chasing metric where you try lots of variables, you assign weights to them, and you say, bring back my top 10 most similar stores and give me an average forecast of those. And I almost work that way to say, well, if I've got 10 stores that look like this, that are in similar places, and they're performing at this level, then I could probably expect that this place, for example, that I'm looking at here, might also perform at a similar level. The problem with that is that it's probably not necessarily the most suited way to get to a store forecasting model. So I think inevitably when you're talking about analog modeling, there is an element of just expertise and experience that goes into that, that's maybe not necessarily just about chasing accuracy. It's about using common sense. So when we're thinking about variables, you might use more categorical variables than maybe you would in a model, for example, in a regression type model, for example. So I think you already touched on retail place.
I was just going to say, our retail place classifications are a great example of something you would use in an analog model, because we describe, is this a retail park, a high street, a town centre, a shopping centre? And that's normally a really good jumping off point for choosing good analogs, because you want to compare other large shopping centres to a large shopping centre if that's your subject site. So those, categorical variables can be quite useful in analoguing, I think.
Yeah, totally agree. And region could be part of that as well, in that London, non-London's the kind of obvious one, where if you show somebody, here's the 10 most similar places to Tottenham, if they're not in London, the immediate reaction is, well, that's not similar to Tottenham, it's not in London. So even if the data says it is, in real terms, it's probably not. So there are those elements, almost human decisions that you have to make when building out.
It is fascinating, isn't it? Because we're talking about how we think about data and how we can explain, rationalize based on our knowledge in terms of your current way of working. Clearly, data has always been a very important part of what you do. Data analytics is a big part of your business. Data is clearly also very important in AI, and AI is the topic of many of these podcasts. How is AI changing what you do from your perspective in Geolytix? From you coming at this from the data angle, I've often argued to people that there is nothing really in AI other than the data that was used to train it. It is fundamentally just the data. Has AI changed the way that you work?
Yes and no. So I think mostly yes. I think we've had discussions internally on before in terms of starting with the sort of data side of it first. There's the whole idea of breadth versus accuracy. So I think the sort of increasing sort of data sources we've got with, say, banking data, for example, or mobility data that we've already touched on today, increasing sort of numbers of open source data sources. The amount of data we have at our fingertips now is much greater. And I think for AI, that's super important because sample sizes, data's number one, number two, and everything in AI is sample size. So I think having that has definitely opened up a lot more opportunities for us to use AI, both from sort of touched on regression forecasting already, but in terms of actually just making store forecasts, but then also in terms of generating other data sets that might provide insight. I think the thing that's most interesting to me is in terms of where AI maybe has solved a modeling problem specifically is probably still where we've got the richest data sets. So for example, where we've got customer data, you can change your whole approach to how you actually build a model. So a typical forecasting model might be, say, at a store level. You might be looking at the surrounding demographics or the data we've sort of talked about today, point of interest data we've not really touched on, but in international markets, that's a really, really important one because it's readily available and we can get hold of that. But you take all of that data and you could, build a regression model, or you could build any kind of model, all great. The problem is your sample size is still maybe 300 stores. So in terms of sort of data science terms, that's still not huge. If you've got, for example, customer data there, or banking data, or maybe some of these other data sets, you can start to really build that sample size in terms of what you're training your models on. And that really opens up quite a lot of potential in terms of building more powerful AI or at least machine learning type models. Yeah. I think one example I'd give is in the grocery market, one of the approaches now where historically we used to use something called a gravity model, which, conscious of time, probably not going into too much detail, and was very popular sort of big box retail type modeling. Now using machine learning, we can start to actually model forecast sales at very low geographies using a mix of customer data and some of the demand data sets that have been built using banking data and that kind of thing. So yeah, definitely opened up more possibilities, I guess, in terms of what we can do.
And I find that very reassuring actually to hear because, I think a crucial part of our discussion and thoughts around AI and AI with reference to data is often how representative is the data that was used to train a particular model. And that's a key element. And we will talk in future episodes about the reliability and transparency of what we do. Fundamentally that relies on, is this data representative of whatever I'm interested in? And I love the kind of the classic thought experiment. The AI walks into a pub and asks the barman, what's everybody drinking? Because, it's kind of getting that idea of actually it's just probability, what everyone else is drinking. Well, everyone's drinking X, that's what I will drink. And that works very well unless you're walking into a pub in, Dublin and everyone's drinking Guinness. Well, that's representative of Guinness in Dublin, but not necessarily everywhere else. And it's that understanding of how representative is the data for what I'm interested in. And it sounds like you guys have got a very strong handle on that based on your past experience. Looking forward, and I guess there's an element of AI context to this question as well, what are the data sets that might be coming along the line that you're most excited about? You've spoken a bit about mobility data. You've mentioned banking data. What else is coming, do you think?
So this is the golden question, I think. So yeah, it's I think I'll start by maybe giving another bit of a cop-out answer and say that we're always looking out for what that next
always looking out for the next one. Yeah,
I'll get that out of the way. Yeah, I think some of the things that are super interesting to me, there's probably two things specifically, and putting a time frame on this, I think, is difficult and sort of where it comes from.
I'm not going to hold you to it.
Appreciate that. So, I think there definitely feels like there's something to me. One of the things that we struggle with maybe in some markets is affluence data specifically, in that can be quite hard to really get if the census quality, say, for example, is maybe not quite as in-depth as it might be in other markets, and it can be quite hard to proxy those things. And they're really important for location planning purposes. So one of the things we've sort of been talking about before was a sort of a wish list, if you like, would be you can usually tell using things like Street View, for example, quite quickly as to, at least in relative terms, the affluence of a particular location. And you can almost identify the kinds of people that might be living there or the kind of retail that's there or whatever it might be. There's a lot that can be gleaned from that. My hope is that at some point, all of that is going to be, we're going to learn from that data and be able to use that in a meaningful way. I don't know how far away we are from that. I'm not even sure if Street View specifically is the right use case, but it's basically another way of seeing what something looks like on the ground and distilling that into a data format that we can use. Because at the moment, certainly whenever we do any sort of projects, we will always still be opening up Street View, referencing, does this look right? Sort of using experience and context for that. But can you get that data in such a way that actually we can use it more directly?
Well, as someone that was responsible for rolling out Street View in Europe, I appreciate your use of that. But I think it's interesting what you're saying, because I guess you're talking more about qualitative views of the world, aren't you? It's not something that's necessarily measurable and expressible by a number, but that feeling of affluence that's represented by the types of cars that are parked there and the types of almost the architecture, that's really important to cover.
No, absolutely. And yeah, I mean, we find that sort of data invaluable. You're right, it's qualitative. That's the word for it. How do we quantify it? Can we quantify it?
Can you quantify qualitative? Very good, yes. Okay, so let's draw this conversation to a close then. Are there any aspects of the work that you guys do at Geolytix that we haven't covered? Clearly data is buried deeply in almost every activity that you guys do. Have we covered everything we should have done?
I think I'm going to drop you in a bit here, Alison, but I think, so Alison's team specifically is the location planning team. And I think just with all of the data talk that we've sort of had today and sort of had, the ever-growing sort of state of AI, etc., I think it's still important that we do sort of observe maybe the limitations of certain data, or in terms of at least contextualizing some of it. And I think, the expertise from actually just having experience of actually opening stores historically is actually really, really important. And I think, we can't afford to lose that, because the actual reality isn't always exactly what you see purely from that sort of maybe more abstract data point of view. So basically Alison's really important. Getting at.
I think it's just that balance we were talking about. It's like all this, rich, amazing data, but it's all, in some cases, there's going to be flaws and there's going to be gaps and there's going to be things that we, in our years of experience of building models and working with clients, we kind of know what to look out for, what to, just sense check, and what's intuitive and what's not intuitive. And as this all explodes and the types of modelling we do explode, and a lot of it becomes a little bit more black box, and we're sort of not entirely sure what's gone into a particular output. I think it's just emphasises even more that we need to be across the data that goes in and understand the quality and understand the gaps, and make sure that's not kind of amplified through the modelling process into something even worse in terms of an output. And I
think that's come across, through my interactions with Geolytix so far. I think that focus on working with your customers, that partnership that you have, and the fact that, this is an iterative process that you learn as you go along, comes across really strongly. And I think, as you both said, there's a risk of amplifying and not really understanding what you're amplifying. And I think the approach you guys are taking seems to be putting in place a mechanism that will stop that. We will always kind of focus back and is this actually giving us a sense of what the reality is? That's really important.
I think we want to get really excited about data, but we are conscious that we still need to be grounded in the reality of, how do we actually use this in a way that's going to be impactful and meaningful, and I guess, not sort of lead us down the wrong path.
That sounds like a perfect point to stop the conversation. Thank you, guys. Really appreciate your time, and look forward to seeing you all for the next Geolytix podcast.